So only combine like terms. And just to remind you guys about like terms mean they have to have the same variable. Oh, I should probably put an E in same. They have the same exponent on the variable. Or they have no variable at all. So I'll show you guys what I mean here with some bullet points and explain it a little bit. So I have 5x to the third plus 4x squared plus 2x to the third, which are like terms.
The 5x and the 2x.
Yep, so these two are like terms because they both have x to the third. So those two are like terms, so we get to combine them. When we combine them, we're going to add or subtract their coefficients, whatever it tells us to do. So we're going to add or subtract these like terms, these coefficients. So the 5 and 2, we'll put those together. When we do that, we're not going to change the variable at all because we're adding here. So this isn't like when we multiply and then we add those exponents. You're going to leave the variable and the exponent as they are.
So like the opposite of what it's
Not really the opposite.
different.
So 5 and 2 is going to be 7. But we're going to write x to the third, so you don't change the variable and exponent. And then that 4x to the second is just going to kind of come along, but we're not going to put those together because they're not like terms. So this would be considered our answer. That's like the simplified version of this.
Is it better if you put the 4x in front?
So good question. So would it matter if we put the 4x to the second in the front? Now it doesn't say this here, but that's one of the things we're going to get used to is that standard form. So that standard form, remember we like putting that highest power first and then the lower power second. So that's just something we're going to get used to today. So we want to write them in standard form as well, okay? So if you guys could flip the page over, we don't have many examples to do, just like 4, but we won't go long, but it's mainly getting those vocab words down at the start. So with simplifying our polynomials, if we need, yeah, go ahead.
Why would you add to the
Because, okay, so, because then you would be multiplying them. Because, so good question. So he asked why we don't add those exponents. So like x to the third plus x to the third versus x to the third times. So those are two different operations. We're adding versus multiplying. This is going to be 2x to the third. So I don't change those exponents at all. Whereas this is going to be x to the 6th. So I add those exponents. So we're adding versus multiplying. So just two different rules. So we're adding here versus multiplying last chapter. Good question. So that's why I wrote that step, because for whatever, and we always want to like change it because we're used to that from last chapter. So leave the variable and exponent the way they are. It's a different rule because we're doing a different math operation. Okay? So flipping the page, the first thing we're going to want to do if we need to is distribute. Now technically in this first example up here, there's not really a lot of distribution to do. There's nothing being multiplied, just like a 1, and multiplying by 1 doesn't really change the answer. So these parentheses really aren't necessary. So I can kind of just drop them off. So we're going to combine like terms. Now as I'm doing that, I'm going to try to do steps 2 and 3 at the same time. So I'm actually going to do standard form right away, and that goes back to Reagan's question, is why was I putting that 1 first, is I'm going to want to write these in standard form as well. And I think your book will say that today. If it doesn't say it today, it'll say it in the next few days. So we want to write that in standard form right away. So which one do you think I should start with up here? Which term should I start with?
The 5x squared and the 3x squared.
Yeah, so the like terms here are 5x squared, and now I'm going to circle the negative, because that negative is with it. So it's 5x squared minus 3x squared.
2x squared.
Yep, so you add the, or subtract the coefficients, and then leave the variables. Okay? Which one am I going to look at next?
3x, negative 3x plus. Look, I don't know, would that just be x?
A little bit confusing. What happens? What's the coefficient? It's going to cancel because it's going to be 0x, and 0 times anything is just 0.
So those go away.
They actually cancel, yep.
Okay, so that'd be negative 1.
And then we're left with just the values without variables. So it's a positive 4, negative 5. So that's going to be a negative 1. So I'm just going to write minus 1. Now, are these two like terms? No, so leave it. That's all we do in this case. And it probably feels very unfinished. You're like, oh, I want to solve that. You don't want to solve these yet. We're not to that point. It's not as easy as it sounds to solve these. So we'll get there later, but at this point, we're just simplifying. Okay? Now this next one's a little bit trickier because there is distribution to do. What distribution needs to happen? Yeah, there is like a negative 1 here that we have to distribute. So that negative is saying we're subtracting this whole second half. So I'm going to rewrite it the way it should look now with that distributed in. So this first one doesn't change at all, so I just rewrote that.
Wouldn't we be on the top one, we distribute that plus?
Technically, but distributing a positive one doesn't change anything.
Oh, okay.
So that's why I
It's
didn't.
negative one that changes.
Yeah, the negative changes all these signs. Because now that's going to become a negative 9y to the 4th. It's going to become a positive 7y, right? 2 negatives. And then a negative 2y to the 2nd. So I just rewrote that so that I have all the signs correct now. And again, I want to kind of do standard form as I'm doing this as well. So what do you want to start with?
Negative 4,
Um,
or the 4.
the y to the 4th, yep. So I'm starting with these because I want, those are the highest powers, and I want to start there so that that's the first one. Now, if you didn't do this, you'll have one step at the end to do to write this in standard form. But we want to start with that highest power first. So I have a a positive 8 and negative 9.
It means negative 1.
Negative 1, or just negative y. And then again, remember the variable just comes along the way it is. Now I'm going to look at those y squareds.
Plus 4y.
So it's a positive 6 and negative 2. So I'm going to write positive 4y so that I have that y to the 2nd because I have that sign to keep that term separate. And then I'm left with these last couple that just have y's. What kind of 2? Positive. Now we're stopped here because none of these are like terms. That's all we do with it. Okay? All right, the last couple are a little bit trickier, definitely the next one, because this one's asking us to actually distribute with a number. So we're going to multiply a number in. Everyone good on this? So this next one, I'm distributing in a 5 here. What's happening in the middle there? What's being distributed? A negative 2.
Negative 2 and the positive 3.
And then the positive 3. So just being careful careful with the signs. That's why I was trying to make sure it was clear. So watching the signs, we're going to distribute those and we'll get what we have then and combine our like terms. Now when we're multiplying, this is a little bit confusing because now we're throwing that multiplying back in. It's okay to multiply on like terms. So it's okay to multiply 5 times 3n. You're just multiplying those coefficients. So that's going to be 15n. And then 5 times negative 4 is a negative 20. So that's my first set of parentheses, like distributed. Then I have this negative 2. And then negative is going to be a positive. It'll be 8n, right? 2 times 4. And this is a positive 3. And that 3 is going to become negative 3n here, squared. Take a minute to make sure you guys are okay with what we got there.
And I believe I solved it. I believe.
Okay, so now we'll combine our like terms. But again, I like to kind of go standard form right away. So I'm going to start with the n squareds this time, because that's our highest power. Now careful when you do that. Notice the signs in front of those coefficients. So that's a negative 2 and a negative 3 that's going together. Yeah, and we're adding here, so it's a negative 5 n to the second. And it's confusing because we just finished multiplying. So a lot of times we see that and we're like, oh, we can, combine those and add the exponents. We don't want to do all that work. We're just adding the numbers in the front. So I have 15n and 8n. They're both positive, so it's going to be 23n, right? Positive. And then finally, I have a negative 20 and a positive 3. Yeah. And then that's it because nothing else is a like term. So that's as simplified as that gets. And then our last one here, what's being distributed? Yeah, again, it's that negative 1's being distributed. If that 8n was being distributed, this would be a much tougher problem. We're not quite there yet. So that negative 1, the 8n to the second is just, that's being subtracted from it. So I'm just going to rewrite that, bring that down. It's going to become a negative 4, negative, so positive 2n. And negative and a positive is going to be a negative 3m to the second. Now this one doesn't have many like terms, and that's okay. We still want to write it in standard form. So this 8m to the second is going to go with the negative 3m to the second. So it's going to be 5m to the second. What should come next?
The 2.
Yeah, the 2m. So the positive 2m, it doesn't have anything to go with, so we just bring it down. Yeah. And then just the negative 4. Okay? Questions there? So use your time wisely for homework. Tomorrow we have ACP, and we do have another Zello lesson. So don't plan on having that time to use for study help. So homework is listed there for you guys. Get this uploaded.